Refraction. So we'll go to the simulation in just a bit. I'll split my screen, but basically we're going to be looking at how how a light source is going to impact or go through two medians here. So we have glass and we have some mystery median. So we call it mystery A. And in a couple of the pictures you'll see in just a second, they'll be turned in different orientations, maybe 90 degrees from what you're looking at here. But it's all the same. We're going through, in this case, glass, and we're going through some other mystery source, maybe water or whatever the case may be. So one of the key things that you're going to be looking at, one of the key equations is going to be Snell's law. And Snell's law tells us basically relative to a normal. Let's get that up there. So our normal is this line right here. That's our normal line. And what it is, it's always going to be perpendicular or sometimes called normal to the line that we're impacting or trying to go through, the median. Let's talk about the different variables involved here. So theta 1, I can get my pen right. Theta 1 will be, doesn't matter which one you pick. So let's just say that theta 1 is going to be the angle that impacts or strikes the first median. So let's let this be the direction that it goes. And now to measure this angle, it's always going to be relative to the normal. So this angle right here is what we're going to be talking about. So let's go down below here and let's look at this picture. This gives us a better view. Now again, we have these two medians. So let's just say over here on this side, all of this, on the side of the horizontal line below is glass. And down below, let's draw that. Let's just say, we'll just make up and say this is water. And so the angle theta 1 is analogous or is the same as what we call, in this case, I call theta G. So let's just kind of relabel that so we have some understanding of what that is. So theta 1 is the angle of incidence. Remember that angle is always relative to the normal. In this case, it's that it's this green line right here. And what we'll see later on, not in this experiment, but we'll see that the angle that hits or impacts this median, when it reflects back, some of the light's going to reflect back. It's going to reflect back at that same angle. So theta G or theta 1 is going to be equal to this angle of reflection. That's just a side note. Now, what we're going to be interested in is we're going to be interested in the angle of refraction. So this piece right in here. And that angle we'll be calling theta 2 in that equation. So let's put that in here so we can kind of keep track of it. So there's my theta 2. Again, relative to the normal, relative to this line right in here. Okay. And going back to our Snell's law equation, V is going to be the speed in which the object is going to be moving in that certain median. We'll have a meter to detect how fast it's going to be going. V2 is going to be the speed of the light as it penetrates through the second median. C is the speed of light. And we'll see later on that it's gonna cancel. So you don't really need to know what that speed of light is. It's some numeric value that we can always calculate. And finally, N1 and N2 are the indices of refraction. So these are the index of refraction. Okay, so this one ties to theta 1, and this one is theta 2. It basically is an indicator of how much the light is going to bend once it goes into a median. All right, so what we're going to be doing is we're going to be setting up our angle of incidence to be at 30 degrees, and we're going to be finding what we call here our thetas of A, which is the same thing as the angle of refraction, which I call down here thetas of 2. So let's get that one. So you're going to be able to calculate that, and you're going to use Snell's law to figure out what the index of refraction as it penetrates the second median down here. So this median is going to have an index of refraction of nth of A, which is this value right here. So using the tool that you have up here, the Snell's law, basically what you're going to be looking at is you're going to be looking at an equation, more than likely thetas of 1, sine of thetas of 1, sine of thetas of 2. You can change the variables as such, is equal to the ratio of n2 over n1. So these variables here get flipped, okay, relative to the index. These numbers get flipped relative to whence they started. So it's a good way of kind of remembering that. All right, so you should be able to plug in. So I did an example right in here. So the index of refraction for glass is 1.5. So that'll be given to you in the simulation. And we'll look at the simulation in just a second. Okay, so you got a couple of things that you're going to need to read through here. So the next thing that's going to be important or critical is the critical angle. And the critical angle is that angle in which all light is no longer being reflected or, no longer being refracted in the light source. So now let's flip over and look at the simulation. The simulation was not being nice in Chrome, so I switched over to Safari on my iPad. Maybe that's just an issue. But before, a second ago, everything worked fine. All right, so here we go. So we have our light source. We'll turn it on. We'll turn on the angles down here in the bottom left corner. And we can set our angle of incidence. That's that 31.3 degrees, which is the same as the angle of reflection. And we can also see the angle of refraction. That's how much bending it does in this median down here. So you can change the various materials that it's going through. So in this case, you have air, water. For you guys are going to have glass and the two mystery medians that you're going to need to find. So the other part that you're going to probably need to work with here, this thing can be a little bit finicky. So if you're using a PC or maybe a finger pad, it's sometimes hard to get to a specific number. So do the best you can. But in terms of just kind of eyeballing it and get some quick answers, you can put your protractor there. Sometimes I use that. You're going to be looking also at the speed of light. Remember, C is the speed of light. So this is 6/10 the speed of light because it's penetrating to glass. So in air, it is the speed of light. And you can see here the speed of that light slows down by about 29% or so. You're going to also be looking at that critical angle. So the critical angle, if you watch, let's move this out the way. If you watch the that refraction angle, there's going to be a point at which this thing goes away. So in air, through this median, it's going to go away at 90 degrees. Let's see what happens when I put glass in this mystery object. Well, let's do glass and water. Let's see what happens. So we can see here that it goes away at roughly, let's say about 63 degrees, somewhere in there. Okay, so that is how you're going to operate with this simulation. And so you can play around with it. You're not going to need to use the time meter here. You can play around with it if you're interested. If you want to play around with the intensity of the light, how much light is absorbed through here, you can kind of play around with that. You can see that some of the light is, in fact, absorbed, about 8%. But the key for this, the key meters that you're going to use are going to be the protractor, and the speed meter here, which will tell us the various speeds as it goes to the medium. You're going to want to pay attention to which medians the light is going through. Okay. And then finally, let's go back to my document here. I've set up an equation right here to look at, and this is a portion of Snell's law. You're going to want to pick off portions of it to get your calculations. And then down below, number 8, you're going to want to go to a source to figure out what two medians, mystery A and mystery B, are. And it could vary now, so depending on which source. So cite your source. Understand that it could be, I'm just going to make up, it could be snow that you're going through as a second source. How much light is refracted once it goes through one source and then goes through snow. So kind of pay attention to that. And then finally, here are 3 pictures just to give you an idea, just from different perspectives, what's going on. The one on the left over here, we just have a light source going through some median. And then you can see that angle right here is that angle of incidence. This angle right here relative to the normal is that angle of refraction. This is how much the light bends. So sort of a different perspective. Over here, this is the the perspective that you'll see in the simulation. And then down below here, you'll see the three different scenarios that we talked about this time, where the angle of incidence is coming up from the bottom through water and then penetrating through air. So play around with that, the simulation, look at it, make sure you get all those questions answered. And if you have any questions, feel free to email or call.